What if I told you that pretty much every change you see in the world, a cake baking, a battery dying, you name it, is really just one of four simple stories being told over and over again? Today, we're going to learn the language of chemistry by breaking down these four fundamental plots that, well, they govern how everything around us transforms.
It's a bit of a weird question, right? I mean, one is super fast and dramatic, and the other is so slow you barely notice it. But here's the thing. They are both telling the same kind of story. It's a story of chemical change. To really get how, we first have to be crystal clear on what a chemical reaction actually is.
And this is the heart of it all. In both that fire and that rusting nail, atoms are fundamentally rearranging themselves. It's like a big reshuffle. Old connections or bonds, they break, and new ones form. That right there is the definition of a chemical reaction.
So here's our game plan. We'll start with the big picture, which I like to call the dance of atoms. Then we'll dive into the four main moves in that dance: combination, decomposition, displacement, and finally, double decomposition.
Yeah, try to think of these reactions less like a complex formula you have to memorize, and more like a dance that only has a few core moves. And once you learn these four basic patterns, you can start to see the choreography happening everywhere in the world. These are our four stories, our four main dance moves. Each one describes a totally unique way that atoms and molecules get together to create something brand new. So let's get started with the first move, combination. Okay, our first story is maybe the simplest one of all. It's about two or more things coming together to build something bigger, something new and more complex. This is the story of combination.
And the pattern here is just beautifully simple. You've got reactant A plus reactant B, and they come together to form one single new thing, AB. It's like two solo dancers linking up to become a pair. It's chemistry's version of a partnership.
And here is where that simple formula just comes to life. On paper, it's just letters, right? Magnesium plus oxygen. But in the real world, it's this incredible, dazzling white light as a strip of magnesium just burns up. That spectacular fire is creating a totally new substance, a white powder called magnesium oxide. That is combination, right there in your face.
All right, let's move on to our second story, which is basically the exact opposite of the first one. So if combination is all about building up, decomposition, well, it's the story of breaking down. So here we're starting with that single, complex compound, AB, and it splits apart. It breaks down into its simpler pieces, A and B. The partnership is over, and the two dancers go their separate ways.
But a breakup like this, it rarely just happens on its own. It usually needs a trigger, some kind of push, an input of energy to get the ball rolling. And that push can come from heat or light or even electricity.
Let's see what happens when we use heat as our trigger. We start with this reddish-orange powder. It's called mercuric oxide. Now watch what happens when you heat it up. The compound just breaks down, it decomposes, and it leaves behind this absolutely stunning silver mirror of pure liquid mercury. A complete transformation, all started with just a little bit of heat.
Okay, our third story. This one introduces a little bit of drama, a little competition. This is the displacement reaction. You can think of it as the tale of a more reactive or stronger element, muscling in and taking what it wants. So the pattern here is all about strength. We have an element, A, and we have a compound, BC. Now, if A is more reactive than B, it will literally kick B out of the compound, form a new one, AC, and leave poor B all by itself. It's pretty much the chemical version of a stronger dancer cutting in.
But of course, that begs the question, how do we know who's stronger? Well, chemists have figured this out, and they've made a ranked list called the activity series. The elements at the top, like potassium, they're the super reactive heavyweights. The ones at the bottom, like gold, they're really unreactive. And the rule is simple. An element can only displace another element that is below it on this list.
Okay, let's see this rule in action. We've got an iron nail, and it's placed in this blue copper sulfate solution. Now remember our list? Iron is higher up on the activity series, so it is stronger than copper. And what happens? It displaces it. The visual proof is right there. The blue solution starts to fade and turn green. That's a new substance, iron sulfate, being formed right before our eyes. And finally, our fourth and last story. Now, forget all that competition. This one is about a mutual exchange. This is double decomposition, or, as I like to think of it, the story of trading partners. So here, we start with two compounds, AB and CD. And instead of one element kicking another one out, they just swap partners. A pairs up with D, and C pairs up with B. And just like that, you have two entirely new compounds. It's a clean, mutual exchange where everyone gets a new partner.
Now, yeah, that probably looks like a complicated formula on the screen. We've got lead nitrate mixing with potassium iodide. But don't get bogged down in the details. Just watch the pattern. The lead, Pb, is about to swap partners with the potassium, K. Let's see what that simple swap actually looks like with real chemicals.
And wow, this is the result. You take two completely clear, see-through liquids, you mix them together, and instantly this vibrant, solid yellow substance just appears out of nowhere. That solid is lead iodide, one of our new partnerships. And when a solid forms from two liquids just like this, we have a special name for it, a precipitation reaction.
So let's just pull it all together for a second. Here they are, our four fundamental stories side by side. You've got combination, building up, decomposition, breaking down, displacement, muscling in, and double displacement, trading partners. Seriously, almost every chemical reaction you will ever come across is just a version of one of these four plots. So why does any of this matter? Because these aren't just abstract ideas for a test. From the way your body digests food to the way your phone battery charges, these four stories are playing out constantly in countless ways, all around you and even inside you. They are literally the engine that makes our world work. This quote really gets to the heart of it. By understanding these fundamental patterns, we get the power not just to see how the world works, but to actually shape it, to create new materials, new medicines, and new technologies.
So I'll leave you with this question. Just look around. The next time you cook an egg, see rust on a car, or light a match, stop and ask yourself, which of the four stories am I watching? What chemical dance is unfolding right in front of me? Thanks for joining us for this explainer.